Hey folks, welcome to my channel Number Pen. So there we have the problem on the screen. Integrate the following with respect to x. We have 5x minus 2 the whole divided by x square plus 2x plus 2, right? So what we've been given is dy by dx and we've been asked to find y. My y is nothing but integral of the given expression. So let's write down what our y is. That's my y, integral of 5x minus 2 the whole divided by x square plus 2x plus 2 times dx, right? So I know that my y is not in a very simple format whose antiderivative I know from first principles. But then when I take a closer look at y, I have a quadratic expression in the denominator and then I have a linear expression in the numerator, right? So the way we go about solving these problems is there a way I can connect the quadratic expression in the denominator with the linear expression in the numerator, right? Now I know that I have an x squared plus 2x plus 2, right? And whenever you've been given these type of problems, right, try to differentiate the quadratic expression and see if you are able to quickly connect it with the numerator linear expression, right? So in this particular case we have an x squared plus 2x plus 2. So let me do what is my d by dx of x squared plus 2x plus 2. It's not very complicated. It is 2x plus 2, right? And then when I look at my numerator, I've got a 5x minus 2, right? So how do I connect these two? And that's what we're going to do in the subsequent steps. And there are multiple ways you can do this. And the way we will do this is I have 5x minus 2. And how do I express 5x minus 2 using a 2x plus 2, right? That's what we're going to learn now. So I copy paste my 5x minus 2. And if I want to write 5x minus 2 in terms of 2x plus 2, how do I go about doing this? Let me assume it is a times 2x plus 2 plus b, right? So this is the way we will express it, which means my a times 2x plus 2 becomes 2ax plus 2a, and then I have my constant b, right? And if I equate this to 5x minus 2, and let me color the corresponding coefficients, right? So my x coefficient is 2a on my right, so let me highlight it in green. And my x coefficient on the left, which is a part of 5x minus 2, is 5. And then my constant on the RHS is a 2a plus b. Let me call it using an yellow color, and let me highlight it using an yellow color. And similarly on my LHS I have a minus 2. Let me also highlight it using a yellow color. Now it's pretty simple out here. We will have to solve for a and b, right? It's not very complex. So my first part is 2a equals 5, right? And take a look at the green portions which are highlighted, which means my a equals 5 by 2. And then I come to the yellow part, which is 2a plus b, which is nothing but a minus 2. Now I already have my a, which is a 5 by 2. So what happens to my b is when I solve for b, after making the corresponding substitution of a in this particular equation 2a plus b, what do I get? I will get my b equals minus 7, right? So I've solved for a and b now. So my a equals 5 by 2 and my b equals minus 7, right? Just highlight that. And now I go back to my y, right? And I have learned to express the linear expression above in the numerator within y in terms of the derivative of the quadratic expression in the denominator, right? And you will see why it makes our integration a lot simpler in the subsequent steps. So let me go ahead and re-express y that way, right? So what happens now is instead of writing my numerator as 5x minus 2, I'm going to write it as a times 2x plus 2 plus b, right? So I'm going to pick this up here and then let's go ahead and make the substitution. So this is my numerator term inside y, And you folks know that we solved for a and b, right? So what is my a? My a is 5 by 2, right? So I'm going to write it as 2.5 here. And then my b is minus 7, right? So I replace my a and b in this particular term, and I hope you folks are with me. I keep my denominator as it is, right? Which is an x squared plus 2x plus 2. So I have my numerator as 2.5 times 2x plus 2 minus 7, and my denominator remains x squared plus 2x plus 2. And let's not forget our dx out here, right? Now, all that I'm going to do is decomposition, right? So when I decompose, remember that you will have to combine your 2x plus 2. So let me highlight that as well in a particular color. Okay. And then you will have to treat the other part, which is 7, separately, right? I've highlighted that in green, right? So now when I decompose this, what do I get? My y equals, I know that my 2.5 is a constant, so I don't have to worry about it. I pull that out of the integral, and this is part 1, okay? And then I have a 2x plus 2 times dx whole divided by x squared plus 2x plus 2, right? When I come to my part 2, I know that my 7 is a constant, so I pull that outside the integral, and remember we have a negative sign. And then I express the second part as dx by x squared plus 2x plus 2, right? Now the second part is not very new to us. We have solved problems of that type in the past, and you know how to re-express the quadratic expression and solve these particular problems. The first part is now a lot simpler, right? Why is that? Because when I make the substitution t equals x squared plus 2x plus 2, my dt becomes equal to 2x plus 2 dx, right? So let's begin with part 1. My part 1 is integral of 2x plus 2 times dx divided by x squared plus 2x plus 2. So let's copy paste that. And the substitution that I'm going to make is t equals x squared plus 2x plus 2. Okay. So what happens to my dt? My dt becomes 2x plus 2 times dx, right? So now I go back to my part 1, right? And let's say call it y1, okay? What do I get if I try and express everything in terms of t? My denominator, which is nothing but your t, and my numerator, which I see that it is nothing but a dt, right? So I'm left with a dt by t. And we know the answer for this is not very complicated, log of mod of t plus c, right? And then I cannot leave my answer in terms of x, so I replace my t with the substitution that I made. My t is nothing but x squared plus 2x plus 2. So all that I get is log of mod of x squared plus 2x plus 2 plus c, right? So that's my y1. Now I go to my y2, and then what is my y2? My y2 is nothing but integral of dx by x squared plus 2x plus 2, right? Now I'm going to rewrite this in the format. I'm particularly referring to the quadratic expression x squared plus 2x plus 2. I'm going to rewrite this in the format x plus or minus a the whole square plus or minus b square, right? And how do we do that? Retain dx, and what happens to my quadratic expression? My x squared plus 2x is nothing but an x squared plus 2 times 1 into x, and then I add and subtract a 1, right? It does not change my expression. My 2x is nothing but 2 into 1 into x, right? So now let me highlight this portion in yellow. You will understand why I did this in particular. My x square plus 2 times 1 times x plus 1 is nothing but x plus 1 the whole square, right? And then I'm left with a minus 1 plus 2, which is nothing but a plus 1, right? So the entire expression x square plus 2x plus 2 can be rewritten like this. Dx by my yellow portion is nothing but x plus 1 the whole square, and the green portion is nothing but a plus 1, which is nothing but a 1 square, right? So what I'm left with is dx by x plus 1 the whole square plus 1 square. Now you see I've brought it to the form integral of dx by x plus or minus a the whole square plus b square, where a and b are constant. In this particular case, you have them as 1. Now let me make the substitution t equals x plus 1, which means my dt becomes equal to dx, right? Now when I go back to my y and put back everything in terms of t, what do I get? So my y2, if I express everything in terms of t, what I get is my numerator becomes a dt and my denominator becomes a t square plus 1 square. So now you see my y2 is of the form integral of dx by x square plus a square, just that in place of x you have t, right? Now our step 2 out here is to connect it with one of the trigonometric identities that we already know, and the right trigonometric identity out here would be secant square theta minus tan square theta equals 1, and therefore the substitution what we will make is t equals 1 times tan theta, right? And which means it is nothing but a tan theta, right? And dt therefore becomes equal to a secant square theta d theta. Now I go back to my y2 and put back everything in terms of theta, right? And allow me to do this in the same line. Take a look at the substitutions what we have done. So what happens to my numerator? My numerator becomes secant square theta d theta. So let me write it as it is. And my denominator becomes a 1 plus tan square theta, right? And what is 1 plus tan square theta is nothing but a secant square theta. So I have a secant square theta in the numerator, I have a secant square theta in the denominator. They get cancelled out, and what am I left with? An integral of d theta. So my integral of d theta is nothing but a theta plus c. You know that I cannot leave my answer in terms of theta. I'll have to put back everything in terms of x. So how do we put back everything in terms of x? We made two substitutions. The most recent substitution being t equals tan theta, and let me highlight it. And then the initial substitution t equals x plus 1, right? So let's go back and first express our theta in terms of t and then do that in terms of x, right? So my t equals tan theta means my theta equals tan inverse of t. So I have my theta in terms of t, which is tan inverse of t plus my constant c, and what is my t in terms of x is of x plus 1, right? So we have solved for y1, we have solved for y2, so we will go back to our y. Coming back to our y, so what happens here is, remember you have your 2.5 and we solved already for y1. So I will have 2.5 times log of mod of x square plus 2x plus 2, right? I'm picking it up from here under part 1, and let me highlight it out here for you folks in green. So that's my part 1 and my part 2. And remember, you have your minus 7 out here. Your part 2 is integral of dx by x squared plus 2x plus 2. And let me go to part 2. And what was that? Tan inverse of x plus 1 plus c, right? Let me highlight that in green as well. So all that we need to do is replace it with a tan inverse of x plus 1 plus c. So there we are. Our answer to this problem is 2.5 times log of mod of x square plus 2x plus 2 minus 7 times tan inverse of x plus 1 plus your constant c, right? So let me highlight my final answer in pink. I hope you found my content useful. Please do subscribe to my channel and support. Thank you.